Okay, welcome to Unit 8, Surface Area. This is lesson 8.1. So we're going to go over a couple little things here. We know different polygons. Now there's a difference between a regular polygon and an irregular polygon. So a regular polygon, it basically has all the same side lengths. Okay, just like a triangle. 3 sides, they would all be the same length, equilateral triangle. Okay, so we know that a polygon for 3 sides is named a triangle. What do we call a 4-sided figure? There's about 6 names.
Square.
Okay, that's one of them. Square. What else? What's that?
Rectangle.
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 Quadrilateral is the perfect term. So, Quadrilateral. Quadrilateral. So, it's a quadrilateral. Those are 4-sided figures. Now again, remember, we have a couple of different 4-sided figures we talked about. We have squares that are all the same size. We have rectangles. We have parallelograms. We have rhombus. A rhombus is a square that's kicked over. Okay, we've got those, what do you call those? These ones, trapezoids. So we have all kinds of different 4-sided figures that we're used to seeing. What if we add one more side? What is a 5-sided figure called?
Hexagon.
Pentagon. There is a famous building in the United States called the Pentagon because it's in a pentagon shape.
Pentagon.
6 sides.
Hexagon.
Hexagon.
Is there a shape for that too?
Is there a shape for what?
No, sorry, is there a building for that too?
No. Well, there's quite a few buildings that are in hexagon shape.
Actually, there's a
Quiet, please. In the 16th and 17th century, they actually liked to make buildings out of octagons. They 8-sided houses. They seriously, like houses and buildings. In the 17th and 18th centuries, you're going to notice that there was more of them. And there's more of them around the equator. Why do you think so?
It's hot.
It's warm. And why do you think they wanted more sides?
To keep the sun from not touching more than one side.
Exactly the opposite. They want to have, so for windows and around the equator, you're going to get more natural light coming in windows, right? Because it's going to be light most of the day. Okay. Number 7. What would a 7-sided figure be called? Nice try. We would think septagon. Heptagon with an H. Heptagon. 8 stop signs. Octagon.
Isn't that what the MMA
9. Nonagon.
What?
Now they're just 50 pounds up.
Well, it sounds like they're made up words, but they're not. 10 sides. Deca. That's why we call it decade. Deca is 10. Decade. So, decagon. All right. 8.
Hydrogon.
Or sorry, 8. 11.
Hydrogon.
Not a hydrogon. Where are you getting that from? Hendecagon.
Where's hens at?
So hendecagon.
So the head is the wait. Don't tell me. Heptagon.
Oh, get this one.
Pentagon.
It's that. Hexagon.
No.
Okay. Now we're going to do 12. 12 is dodecagon. Whoa. Yep, dodecagon. Now, the general name, like so for n-sided, so n-sided is going to be n-agon. So, the n is the number of sides.
Oh, really? So it's like 12 and up there up and everything.
27.
Your prefix we've got an isosagon. Isosagon is 20 sides. So So a 20-sided polygon, that is on the game show. What game show was it? Price is Right. Good. The Price is Right. It's not Jeopardy. Now, take a look at what the ending word is. Agon. So, when we've got the agon part of it, that means your sides. How many sided polygon you're dealing with. Alright. Now we're going to talk about concave and convex polygons. Who remembers what a convex polygon is? What would a convex polygon? Anybody? So, convex means every angle is going to be smaller than a straight line. Okay? So they got to be less than 180. So if we take a look at, let's just do a hexagon. If we do a hexagon, each angle is less than 180 degrees, and that's for convex. Okay, that's a convex object. Now we're talking about each interior angle. So that little teepee that I just drew right there, that means that in between those words, that word interior belongs in there. So each interior angle, so that's the inside angles, the ones on the inside of the object. Okay? So each of those is less than 180. Yes, sir.
So then there's concave.
Yeah.
Is that more than 180?
Close. It has one angle that's more than 180. So I'm going to just draw a diagram. We'll try and draw another six-sided figure. So this is a large angle. So at least one angle on the inside is greater than 180 degrees. Okay? So on the inside, this guy right here, that'd be called a reflex angle. Because it's greater than 180, it's quite a big angle. So that's for concave. So think of it this way. The object has one of its points, one of its vertices is caving inside the object. Okay, and that's the way you can remember that it goes inside the object. So that's concave object. What would perimeter be? How could I define perimeter if I wanted to use my own words? If I said you find the perimeter of the room, what would you try to do? Measure the exterior. Good. So you'd measure the length of every wall. So that means the perimeter means you add all sides of the object. Now, since we're adding sides, and the sides are all lengths, since I'm only measuring lengths, my unit is centimeters exponent 1. What does that exponent 1 mean? Do you remember what we talked about with that exponent 1? It's flat. What else do we know about exponent 1? I measured one thing only, length. The length of that one, all the way around. That's measuring length. That gives me perimeter. So if I'm only measuring one item, that's what this shows us. That shows me one dimension. Okay, remember? One-dimensional versus two-dimensional versus three-dimensional. So we have 1D objects, 2D objects, and 3D objects. So when we're dealing with perimeter, we're only dealing with one dimension because we're measuring one thing, and that's length. Okay? What about area? How is it different from perimeter? Am I still only measuring one thing? No. That's right, you're measuring the amount of space for the inside of an object. So how do I do that? Good. So we measure 2 dimensions, which is usually length times width, which is going to give us our units. Typically are in centimeters, and they're going to be squared. And the reason they're going to be squared is because it's dimension 2 dimensions. Now again, defining area, just like Zane said, it's the amount of stuff inside an object. If it's 2-dimensional, we can't have an inside of an object per se, because we're not filling anything, except for we can shade it, right? We can color it in or shade it. So because of that, measuring 2 dimensions for area, area is the space an object covers or takes up. Okay, so if I wanted to know the area of this room, that tells me how much space this room takes up in the whole school. That's what the area is telling me. How much space would it take up? Okay. So what do you remember for, if I were to just draw a square? So let's just say this is a square, all sides are the same. How would I find the area of the square? Length times width, good. So we've also got a base, we have a height, it's also called length and width. Okay, they are interchangeable words. Now, if I were to cut this guy in half, okay, if I were to find the area of this guy here, the area of my square, so area, and I put my little square there so I know it's area of the square. Well, that's going to give me length times width, or base times height. Okay, whichever you prefer. They both mean the same thing. Now, with a triangle, if it's not a right triangle, so if you don't see a 90-degree angle, then you have to find the height of the triangle, and that becomes your h. The longest side here becomes your base. So, how much of a triangle would this square have? How many triangles could I put in that square? Yeah, 2. Good job. So I could just cut it like this, and I would have 2 triangles. Well, if I'm cutting the square in half, the triangle is only half of the square. Well, that means his area for the triangle is only going to be half of this. So the area of a triangle then is this. Area of a triangle is base times height, but it's only half of it, so it's divided by 2. Okay, so it's base times height divided by 2. Now in this case we don't use length and width because we actually need the height of the triangle. Now if it's a 90-degree triangle like this, you would use base and height. Okay, the base and height are attached to the 90-degree angle. Okay, always, always. So you would never use that side, the hypotenuse. You'd never use that. Not if you've got a 90-degree angle. Okay, so to find area, you don't use the longest side. Okay, you use base times height for a triangle. All right, now we're going to go back and we're just going to see if we can concentrate on some quadrilaterals, some 4-sided shapes. So we have a square. We already said the area of a square is length times width, or base times height, but we could also say something different for a square. What do we know about squares? The sides are the same. So if this guy's a 10, this guy's a 10, and so on, all the way around. So if I want to know the area, I would take 10 times 10. Now, if the number is identical, I could just say that number squared, meaning there's two of those numbers. So I could say it is the side length squared. So you're often going to see this as well. So there's three separate equations you could use, or formulas. So length times width works, base times height works, and so does side squared. Okay? Now perimeter, we want to add up all the sides. If I wanted to add up all these sides, I'd take 10 plus 10 plus 10 plus 10, and I would end up getting 40 over here. Okay? But if I wanted to write an actual perimeter statement, I would say it is this. 4 times the side length. Or you can put 4 times the length. 4L or 4S. So in this case, I would go 4 times 10, and that would give me my 40. Okay? And that's how we find perimeter and area of just a square. Okay? Now we're going to take a look at those other 4-sided figures. Ready to move? All right. We have a rhombus. And what do we know about a rhombus? It's a square that was kicked over. He was pushed over. So that means all the sides are the same length in a rhombus. Okay? So, area of a rhombus is going to be base times height. Okay? Now, whenever you've got a slanted diagonal side, you're never going to use the slanted line. So what you have to do is we are going to draw a vertical line down and call that the height, because that is the height. That's the height you would use. So you would use a horizontal for your base, and then you draw your vertical height. Okay? And this always applies when you have diagonal sides. Okay, so base times height. Now, what do you think I could do for my perimeter of that object? What do you think? Would there be any changes from the perimeter formula of a square?
No.
No. There's 4 sides, and they're all the same. So we could say perimeter of a square is, of the rhombus is 4 times the side length. Same as a square. All right, rectangle, a basic rectangle. Well, your width is always your shortest side, and your length is always your longest side. But we could also call them base and height, okay? Height will be the width going up and down, and base will be the length on left and right. So we could say area is length times width, or base times height. Now, how would we do a perimeter if all of our sides are different? Although it's kind of like the front of a Kleenex box for a rectangle. We have the vertical sides are the same, and the horizontal sides are the same. Okay? So some of the sides are the same. So how can I write that as a formula for perimeter? How can I say that? Well, I could do it a couple different ways. Go ahead, Peyton. Yeah. So length plus width plus width. Now we could say this easier. How many W's do I have? How many L's do I have? Good. So we could also say 2L plus 2W, because they mean the same thing. Okay? Again, you're just going to add up all the sides all the way around. Okay? All right. Let's take parallelogram. 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 Again, it's got a diagonal side, so we have to find the height. And we use the base. So the area is going to be base times height. And our perimeter is going to be 2 times the base plus 2 times the height. Or sorry, we don't use the height. We would actually use the slanted side. So we could actually just use the same thing as this guy up here. 2L plus 2W. 2 lengths plus 2 widths. Okay? Basically,
Just because it would be a rectangle.
yeah, you betcha. It's a rectangle that you just kicked over. Now, a trapezoid, you've got a shorter side on top called A. You have a longer side on the bottom called B for base. And then we've got an H, again, for height. Okay? Because we have slanted sides. So when we want to do area of this guy, the area is going to be A times the H plus B times the H, all divided by 2. Okay? At the top would be in brackets. And perimeter, again, you're going to add all the sides. Add all 4 sides. Okay, so now we're going to go back to our metric system and just review our metric system. So, again, an acronym to remember, a little word or a phrase. So we've got Kermit has dandruff, but doesn't care much. We use B for but because it's a base unit. So meters is our base unit, but we have 2 other base units. So meters measures distance, okay? So kilometers, meters, centimeters, that's distance or length. But if I wanted to measure, let's say, something that's a liquid, I would then change my base unit to liters. Okay, so your base unit can be liters if it's liquids. Liters is for liquids. And the other one is grams. And grams is for solids. So I don't know how many of you have parents that like to cook, or maybe they use like a measuring device for their cooking. So they might measure out the amount of meat they have, how many grams of meat, how many proteins they have, all these kinds of things. Okay, so whenever you're actually measuring things at home, and if it's a solid object or solid food, you're measuring it in grams. Okay, so we have grams for solids, liters for liquids, and then meters is distance. We're used to doing the distance one. So how can we remember this? Well, there's a couple different ones. We have Kermit has dandruff but doesn't care much. We also have something drank my dark chocolate milk. King Henry, okay, so King Henry drank my dark chocolate milk or something like that. So there's a couple different ones you can remember if you'd like to remember those, okay? Now, when we move our decimal place, if you don't see a decimal, where is it always hiding? On the right, good. So if you don't see a decimal, you can always draw one in. So this guy here has a decimal right there after the 12, here after the 2, here after the 3, and here after the 6. So that's where our decimal's hiding. And now we're going to move them according to where they want them to go. So this first one is at kilometers, and I got to move all the way to meters. So we're going to count how many steps. 1, 2, 3 steps. So that means I'm going to times by 10 3 times, or I move my decimal place 3 times. And what I do is I put zeros in place of where I moved it. So it's going to be 12 and then 3 zeros. So 12,000 meters, okay? Because what we actually did was we moved our decimal place that was here, we moved it 3 places and put it right there. That's what ended up happening, okay? So we moved it from after the 12 to after that 0. Okay? So the places, you're going to notice that I moved it, I had to put zeros there. Okay? Because they're the placeholder. I had to put a 0 there. Alright, now we've got millimeters, we're going to centimeters. So now I'm way over here on the right, and I'm moving 1 to the left. Well, 1 to the left means I'm going to divide by 10, or move my decimal 1 to the left. So my decimal is here. I'm going to put it between the 5 and the 2 now. So I'm going to have 15 decimal 2. The next one, we're moving to the left again. We're going centimeters to meters, so that's 2 steps I'm going. So I'm going to go 2 steps to the left. So my decimal goes between the 5 and the 2 again. So we're going to have 3, 5, decimal, 2, 3. And the next one, we're now moving the opposite way. We're going to be moving to the right, and we're going to move 2 spots. So 2 points to the right. So move my decimal 2 times to the right. 17600. So 17,600 you should get. All right. So how do we convert squared units though? So single units are okay to convert. We just move them up and down. But how would we do it if I said I was dealing with area and my answers were squared? Or if I was dealing with volume and my answers were cubed? How would I convert those ones? Well, we've got a bit of a rule. So the rule says we count as many steps we need to go, and then if it's squared, we double it. If it's cubed, we would triple it. So for example, let's just take our very last example that we did. I was going meters to centimeters. So meters to centimeters, I moved my decimal 2 times. Okay? Now, if it was centimeters squared to meters squared, I'd move it 2 times, and because it's squared, I'd double it. What's 2 doubled? 4. So I'd have moving my decimal 4 places. Okay? So we're going to do an example to show that.
What is PAM stand?
What's the what, sorry?
PAM.
Decameter. Yeah. No, it's decameter. Okay, squared units. So our squared units here. Here's our example. Let's just go 1, 2, 4, 7, 8. And we'll put a 9 on the end. We're going to say that is centimeters squared, and we're going to go to meters squared. So we already discussed that's moving our decimal 2 times, but then we got to double it. So that's going to be moving 4 times. Right now we have a hidden decimal. It's sitting right there after the 9. Now I got to move it 4 to the left. So 1, 2, 3, 4. It's going to sit in between the 12 or the 2 and the 4. So we get 12.4789 meters squared. Okay. So how did we actually do it? You move the number of steps. Whoa. Oz, not Oz, of doubled. Okay, so you move the number of steps doubled. So you count how many steps it would take, and then you times that answer by 2. And if it was cubed, what would you times your answer by? 3. You would triple it. Okay, so let's take a look at rounding. These are all just reviews. We should know how to round already, but rounding is something that we get stuck on quite often. So when we round, we have to realize where all these decimal places are. So if I've got this number right here, 234.5832, whenever you want to round to a certain place value, you look at that number, and then you look at the number directly right after it on the right-hand side. It's that number that's going to decide whether you add 1 or you leave it. Okay? How do you know if you're going to add 1? 5 or bigger. Good. So 5 or bigger, add 1. 0 to 4, you're going to do what? 0 to 4, you're going to leave it. Okay? You're going to leave it. You won't round it. Okay. So nearest 10. So I'm going to circle the 10. That's the 3. So what number comes after that 3? A 4. Is that 4 going to make that 3 bump up? No. So we're going to go 2, 3, 0, 230. That is rounded to the nearest 10, 230. All right, hundredth. So hundredth, now whenever it's got a TH on the end, you have to look after the decimal place. So TH on the end, we're looking at the 8. So if we look at the 8, we got to look at the number after the 8. What number is after the 8? 3. Is the 3 going to make the 8 add 1? No. So all we do is we just cut it off then. So we'd have 2, 3, 4, decimal, 5, 8. You just don't write the other numbers. Okay? Follow along and write this down, please. Nearest whole number. So we're going to look at the number to the left of the decimal, and then we're going to look at the number directly right after the decimal. What does this 5 tell the 4 to do? Yeah, it tells them to add 1. So we're going to get 235. Okay? Now if we want the nearest 10th, that's the 5. So if I want to do 10th being the 5, I have to look at the number after it. What does that 8 tell the 5 to do? Add 1. So we're going to have 234.6. The 5 will add 1. Okay? All right, let's do some examples of converting. So I'm going kilometers squared to meters squared. So kilometers squared to meters squared right here. So if I just write my kilometers, hectometers, decameters, I got my meters, decimeters, centimeters, millimeters. Okay, so I'm going from here to here. So how many steps would that give me? 1, 2, 3 steps. But it's squared, so what do I have to do to that 3? Double it. You got to times it by 2. So it's 3 times 2. 6. So I'm going to move my decimal 6 times to the right. So 1, 2, 3, 4, 5, and 1 more. So I got to put a 0 at the end. So I'm going to have 1, 4, 7, 5, 6, 9, 0. That is my number. 1,475,690. Now we're going the other way. Now we're getting smaller. We're going to go, oh no, we're getting bigger again. The number will get bigger, I guess, but the units are smaller. So meters cubed to centimeters cubed. Now, I'm going to put a decimal in here. The decimal is missing. The decimal should be between the 5 and the 0. So please put the decimal in the 5 and the 0. So now meters to centimeters cubed. So if I look on the bottom here, I want to go meters to centimeters. That's 2 to the right. So 2 to the right, but it's cubed. So what am I going to times the 2 by? Times it by 3, and you're going to get 6. So we're going to move the decimal 6 to the right. So 1, 2, 3, and then what do I got to add to the end? 3 zeros. Good. So 2, 7, 5, 0, 8, 4, and 3 zeros. Perfect. So 275,084,000 centimeters cubed is what it ends up being. Okay. Backing it up to unit 8 or 7, we talked about circles. What is the difference between a diameter and a radius? Diameter and a radius, Tyler?
Radius is half the diameter.
Good. So radius is halfway across, diameter is all the way across. Okay, and they both go through the middle. The radius would be from the middle. Formula for area of a circle. Area of a circle is pi times radius squared. Pi times radius squared. What term do we refer to use for the perimeter of a circle? Circumference. Good. We use the word circumference. So we don't actually say, hey, find the perimeter of a circle. We say, find the circumference of a circle. All right, so we can write the formula for the perimeter or circumference of a circle in 2 ways. Okay, so there's 2 ways. So circumference is equal to pi times diameter. And how many radii make up 1 diameter? 2 of them. So we could have it saying, or 2 radius times pi. So 2 pi r. Okay, so 2 pi r. Because the 2 radiuses are equal to 1 diameter. That's why we have 2 different ways. So how is pi calculated? Circumference divided by diameter. Or circumference divided by 2 radii. And the 2 radii would be in brackets. 2 times radius. All right, we're going to do a few for example now. So we're going to try and actually use our formulas. And we're going to calculate areas. So let's see how this goes. All right. So we want the area of the following shapes. Well, the first one on the left is a rectangle. And rectangles we know are area is length times width or base times height. So I'm going to take 4 times 7 and I'm going to get 28 centimeters squared. Okay, 28 centimeters squared. Don't forget your units. All right, we're going across the top. Now that's a parallelogram. We got a parallelogram, so we have base and we've got height. Area is equal to base times height. Base times height. So we're going to get 8 times, 6.5. Why did I say 6.5? They're different units. One's meters, one's centimeters. So I chose to put the centimeters into meters. So that's 6.5 meters. So you have to make sure your units match before you actually do your multiplying. If we look on the left one, we have centimeters and centimeters. The units are identical, so we're fine. So this guy, we had to move our decimal, which is hiding after the 0. We had to move it 2 places to the left. That's why it became between the 6 and the 5. So 6.5. So now we're going to take 8 times 6.5, and that's going to give us 52 meters, not centimeters, pardon me, meters squared. Now, could we find centimeters squared if we wanted to? Yes, because we know that we can take a centimeter squared and convert it to meters squared and vice versa. So I could take meters squared and go to centimeters squared. So if they wanted the answer in centimeters squared, perhaps. So I would take my 52 and I would times it by 100 twice. I've moved my decimal 4 times. So you times it by 10 4 times, which is 10,000, or you're just going to add 4 zeros to the end. So we get 520,000 centimeters squared. So remember, how many spaces would we have to move it from meters to centimeters? We would move it 2 to the right, but because it's squared, we had to double that, which is 4. That's why we have 4 zeros. Okay? Now that's if they wanted it in centimeters squared, so be careful about your units. Now we're going to do the triangle. Now we're going to do the triangle. So, on this big bad triangle right here, we have a base and we have a height. So the area of the triangle is base times height divided by 2. So 4 times 5 divided by 2 is going to give me 10 centimeters squared. Okay. Right beside it, I've got a circle. My area of my circle is going to give me pi times my radius squared. So that gives me 4 pi. And 4 pi gives me 12.57 millimeters squared.
Hold up.
Whoa, whoa, whoa.
Oh, yeah.
Whoa.
What?
All right. Okay, our last 2 examples. What is the difference between this green starred triangle and the triangle circled in blue?
It's a right triangle.
Thank you. It's a right triangle. When it's a right triangle, we use the base as the bottom and the height is the vertical. So we always have them. They're attached to that 90 degrees. We don't use the diagonal line. So area is going to be 8 times 6 divided by 2, which is 24 centimeters squared. All right, the next one. We have a trapezoid. And trapezoid says we have to do this. Area is A times height plus B times the height, all divided by 2. Well, A and B are your horizontal ones. They're your short and long sides. So A is usually on top, B is on the bottom. So we're going to say A would be 10 times 4.5 plus 8 times 4.5, all divided by 2. Now, because it's in fraction form, we have to solve the top completely to one number before we can divide by 2. So again, bed mass applies. We've got to do the multiplying and the multiplying before we can do the adding. So that's going to give us, what is 4.5? It's 45 plus, is that 36?
Yep.
All divided by 2. So that's going to give us 81 over 2, which is 40.5. And our units are centimeters squared. Okay? The units are centimeters squared. Now, this formula on top, you will also see it written as H times A plus B. Okay, you can also do it that way, because that's the distributive property. What happened to H, you multiplied to A and you multiplied to B. That's how we get this. Okay? All right. That concludes the first part of 8.1.